Kia ora koutou. This is a great question that Andy sent in from this year's 2023 Pure 3 paper. It's a complex numbers one, and most of the work is actually in the first part of this question. The second part looks daunting, but it's not. We have to take the number that we find in part one, cube it, and write it into exponential form. And exponential form for a complex number is really, really easy as long as you are confident with polar form, because the r and the theta in polar form are the same as the r and the theta in exponential form, right? Now that's done in the very last part of the Pure 3 textbook, right? And we didn't spend that much time on it in real life or at university. If you go on and do more stuff with complex numbers, you're probably going to end up working extensively in exponential form. It's something that doesn't come up at all in level 3 calculus, and it just comes up in questions like this one in Pure 3. I also haven't seen it in any scholarship calculus papers. Anyway, what we're going to spend most time on in this question is actually part A, which is one where we're told that this complex number z has got a in it, and we're told that argz is equal to negative pi on 4. So if we draw up our axes, if something's got an argument of negative pi on 4, that means that it's sitting in this quadrant, and it's a very nice complex number. For example, it might be 3 minus 3i, right? Or it might be 11 minus 11i, right? So if it's going to be on that ray, it has to have matching coefficients here, and it has to have a minus sign in it. So we're told that z is equal to this, and we have to work out what a is. So z is equal to 5a minus 2i over 3 plus ai. I'll just check that I've copied that right. Yep, that's right. Now we're going to multiply by the conjugate over the conjugate as usual. So I want you to pause the video and work through this and then go through it with me. In the denominator we get 9 plus a squared, and in the numerator we get 15a minus 6i minus 5a squared I plus 2a I squared. And when we group real and imaginary, we get 15a minus 2a over 9 plus a squared minus 6 plus 5a squared I over 9 plus a squared. And we can rewrite that as 13a over 9 plus a squared minus 6 plus 5a squared over 9 plus a squared I. So that still looks a little bit daunting until we go back to our picture and realize that all we've got to do now is use this fact here, right? So since the arg of z is equal to negative pi on 4, we know that 13a over 9 plus a squared has got to equal 6 plus 5a squared over 9 plus a squared. And we can times both sides through by that, and that leaves us with a babyish quadratic. So 5a plus 6 is equal to 13a. Let's get everything to equal 0 first. So 5a squared minus 13a minus 6 equals 0. Whoops, plus 6 equals 0. Okay, so it's worth checking at this point that I haven't screwed anything up before I go ahead. So just check back through your work. Okay, so that all looks all right. Be careful here with the grouping that you haven't mucked that up. That's another place to make a mistake. And just be careful that you have multiplied by the conjugate. All of those tiny checks are worth doing on the way. Now, factorizing this, I'm probably going to have 5a and a, and I've got a plus here, and I've got a minus here. So I must have a minus-minus pattern. So there are a few things I can try here, but if I look at this, it's not going to be 1 and 6, right? That's not going to work. It's not going to be 6 and 1. It's going to be some combo of 2 and 3. So if I do a 3 here and a 2 here, that's not going to work. That would give me negative 17a. But if I do it the other way around, I get minus 10a here and minus another 3a here. That gives me a is equal to 3/5 or a is equal to 2. So now I look at this and I go back to the question and I'm like, oh, didn't it just want one solution for a? So we go back and we reread. And we clean up all this mess. And we see that a has to be an integer. So that means that we're going to reject a as 3/5, and we've just left with a is equal to 2. So we reject a is equal to 3/5. Now, it's very easy now to work out what z is. Substituting in here, what are we going to get? Let's have a look. So that's where I want to substitute. Right, so z is equal to what? Well, 13a, so 26 over 9 plus a squared. A squared is 4. This is looking pretty nice. And then I'm going to have minus 6 plus 5 times 2 squared, which is 4, also looking nice, over 9 plus 4i. So z is equal to 26 over 13, 2 minus 2i. Excellent. That's the first question done. That's the first 6 marks, right? So hopefully you can see where this is going now. We have to express z cubed in exponential form. Right, so here's my picture of z. Z is 2 minus 2i. So the magnitude of z, so this is 2, this is negative 2 down here. This is just a scaled up 1, 1, root 2 triangle. So the magnitude of z here is going to be 2 root 2, which is just the square root of 8. Either of those is fine. And the argument of z, we're told, well, we know just from what we've just done, is equal to negative pi on 4. So we can write z as root 8 cis of negative pi on 4. And we can very easily now cube z. So this is now getting well into part B. Let's just deal with this. So z cubed is equal to root 8 cubed cis of negative 3 pi on 4, and that's by de Moivre's theorem. All right. If you're watching this and you're not understanding where that came from, you need to go back to some of the teachy, slower videos going over how we multiply and divide and do powers with complex numbers. So z cubed in polar form is going to be, well, what have we got? It's going to be 8 root 8, which I don't like. That's not fully simplified, but that's what it is. Cis of negative 3 pi on 4. So pulling out the 2 from in there, we get this. So z cubed works out to be that in polar form, which means that in exponential form, it's going to be 16 root 2 e to the negative 3 pi on 4i. Okay, so that's the final 3 marks for that question. Thanks for watching. If you have got any questions on exponential form, either just send me an email or go to, I think it's chapter 11G. It's one of the very last ones in the textbook.